Section 7.5 takes a close look about how graphs look. So we're going to talk about different intervals of a graph. And we are going to say that they are either increasing, decreasing, or remaining constant. So if you take a look at part 1 here, an interval is a period of time between 2 points of time or events. So we are going to take a look at the graph right here about time and speed. And we are going to label the 3 intervals as either increasing, decreasing, or remaining constant. So what we're going to do is we're going to read a graph from left to right, just like we read words from left to right. So if I were on a roller coaster, or if I were on a bike or in a car and I was driving and this was the path that I took, I would say that on the roller coaster I'm going uphill. So if that's the case, I am going on an interval that is increasing. So right here, this interval right here is increasing. And once I get to the top of that part here, then I start going straight across. So I would not say I'm going up, so I'm not increasing, but I also am not decreasing. So this interval is called a constant interval. So it's when we have a horizontal segment that is a constant interval. And then at the end of that horizontal segment, the graph goes back down. So this interval is said to be decreasing. So let's take a look at the next graph on our paper. And this is talking about the time versus the height. And it's probably talking about a ball of some sort. So the time in seconds, as those increase, what happens to the ball? So the height of the ball goes up in the air, reaches a point, and then comes back down. So this interval S, until it reaches the peak of this graph, is said to be increasing. So what type of interval is interval S? We would say, since we read a graph from left to right, it's going up, so that is an increasing interval. And although it doesn't ask what interval t is, I would like for us to write it anyway. So interval t is starting up here at the peak, and the graph goes down, so interval t is a decreasing interval. So in the bottom example, it asks us to label the graphs to indicate which intervals are increasing, decreasing, or constant. So I'm going to say that this interval from here up to this peak here, that interval is increasing, and then from here down forever, that interval is decreasing. So I'm going to just separate that with a line here. So I would say that this interval is increasing because we read a graph from left to right. And then this other side has an interval that is decreasing. Now if we move over to part B, reading this graph from left to right, we have a horizontal segment, so that part of the graph is a constant, and then it increases, and then it goes constant again. So I'm going to have 3 different parts to this one. So this one here, this interval is constant. This interval that goes up here is increasing. And then the top interval up here is also constant. All right, let's go ahead and move on to the back side. Part 2, got it. Label the graph to indicate which intervals are increasing, decreasing, or constant. So if we follow the graph from left to right, I would say it goes up here, so that's increasing, and then it goes down here, so that's decreasing. So this interval here is increasing, and the interval here is decreasing. All right, and then part 3, we have using graphs to evaluate. So the first question is, how many constant intervals are described in the graph? This could be interpreted 2 different ways. So first of all, the constant intervals are the horizontal segments. So we have 1, we have another one, so that's 2, 3, 4, 5, and then it's not really clear on this graph, but let's say that this graph actually does go to 8 o'clock. So that would be 6 intervals. 1, 2, 3, 4, 5, 6 intervals are constant. So let's go ahead and write that there. How many increasing intervals are described in the graph? So increasing means it goes up from left to right. So here it goes up, so that's 1. Here's 2. And there's 3. So there are 3 increasing intervals. Decreasing intervals would be 1 here, 2, and 3. So we have 3 decreasing intervals. Now let's talk about what the constant intervals represent. And in order to do that, we really need to focus on the words. This is speed, and this is time. So I would say that from about 5:10 to, just before 5:30, so maybe 5:20 or so, in that time frame, the speed of the car stayed at 20 miles per hour. So that speed remained constant, and that's exactly why we say it's a constant interval, because the speed remained constant. Down here, the speed is 0. So that means the car was stopped, assuming we're in a car. Here, this interval means that the speed of the car remained constant at 30. So it had a constant speed of 30. Here the car was stopped again, and here the speed of the car was 25. So the constant intervals represent when the car stayed at the same speed. The next question asks, what do the increasing intervals represent? So that's here, and here, and here. So the speed goes from 0 up to 20 in this interval. It goes from 0 to 30 here, and it goes from 0 to 25 here. So those intervals represent when the car was accelerating or speeding up. And finally, the decreasing intervals, which are found here, here, and here, represent when the car was slowing down. And in this case, it was slowing down to a complete stop. The same with this, and the same with this. So it's when the car was stopping. And that summarizes the notes for section 7.5, increasing, decreasing, and constant intervals.